is 2 pi r, and so if the circumference was exact, then 2 pi r should equal 84, meaning that 84 divided by 2 pi should be our r. I'm basically going to leave that exact, but I guess we could write it as 48 over, no, that's not right, 42. Okay, so that's my exact original x value. And again, I think I'm going to purposely leave it exact. But they said they could have been off by 0.5 centimeters. The way they have it phrased, a possible error, this is a good epsilon delta example. So just a little review, this would be like my A, this would be like my L. The error in the circumference could be at most 0.5, which means it might be 0.5 smaller or 0.5 bigger, but they're asking us this. So which side do we want to go on the 84? Above it, right? Because if the circumference was slightly smaller, then the surface area is going to be slightly smaller, and they want to know, well, you know what, I guess they are asking for maximum error. Because surface area is going to be squared, your error is going to be bigger on the higher side. Okay, so we don't really need to check both. Okay, so my delta x, but in this case it's r, which equals my dr, is 0.5 centimeters. And so my r plus delta r is 42 over pi plus 0.5. Okay. Again, I'm only testing the upper bound because surface area is a squared function, and so the error is going to be higher with higher numbers. Okay, so surface area of a sphere is 4 pi r squared, is the formula for the surface area of a sphere. So surface area of the sphere at, where is that? At 42 over pi would be equal to 4 pi times 42 over pi squared. Again, I'm purposely trying to leave these as exact as possible. Let's see, does somebody want to square 42 for me?
1764.
1764, okay. And then multiply that by 4.
Confirmed.
It's 1764.
Oh, 1 7, sorry. Yeah. And then multiply that by 4.
7056.
7056. Okay. So square centimeters. Okay, so that's the exact surface area. Just by the way, that's our exact surface area at that value. But we want to know what the maximum error is, and they're asking us to use differentials, okay? All right, so I'm just finding what the exact area should be, but they want us to use differentials to find the maximum error. So what they mean by that is they want us to find ds dr, but then you're going to multiply both sides by the dr. But first we need to find the derivative, ds dr. My formula is the surface area formula. So I get 8 pi times r. Is everybody following where I'm getting 8 pi times r? I took the derivative of the surface area, and 4 and pi were just coefficients, and I just need to do power rule. Okay, so then my differential then is that times dr. Okay, that's the differential. So 8 pi times 42 over pi, and then what was DR?
42 over 5 plus.
What's
0.5?
DR?
Point, oh, yeah,
0.5, yeah, 0.5 is the DR. Okay, so 8 pi r is this, and then DR itself is this. And I get, what's 8 times 42? Would be 320 plus 16, 336 times 0.5. And half of 336 would be 150 plus 18, 168, is that right? So, I'm gonna check double check my arithmetic. All right, so this is using differentials to approximate the maximum error. All right, that's what they asked us to do, and that's what we did. Okay, that's what this answer is here. Then they're asking us to find the relative error. What they're asking for there is they want us to compare how big the error is to what my value is supposed to be. So that's why I took the time to find this, okay? So my relative error, I'll try to fit it in over here. My relative error is 168 divided by 7,056 over pi. Let me go ahead and turn that into, because pi is gonna, for it to make sense to us, we probably are gonna wanna kind of think of it in percentages, so. So 0.075, so approximately a 7.5% error. So being off by 0.5 centimeters creates a surface area error of about 7.5%. It may be helpful at this point to sort of compare that with if you actually found the surface area at 42 over pi and then found the surface area at 42 over pi plus 0.5 and see how close our differential came. So we could do that. We already know that 42 pi, that's my surface area. So if I took 4 pi times 42 divided by pi plus 0.5. We want to square that. Okay, so at the higher, sorry. The right button here, okay. At the higher radius, this is my surface area. So this is the surface area of the sphere at 42 over pi plus 0.5. That's what that is. And then the surface area at 42 over pi was our 7,056 over pi, which is approximately 245. Well, we've got both answers up there. Okay, 7,056 over pi is approximately 2245.99, and so the 2417, so new minus old, 2417.136 minus 2245.995 is 171, okay? So this is delta S. All right, that's delta S. And then what we have over here is DS. So again, they're off a little bit, but I think this was a good example because I do think it was quicker to find DS in this case. Our derivative was clean and simple. And so, as opposed to the last example we did, dy was a little messier. So it kind of seemed easier to just find delta y, whereas here, I think it took a little more work to find delta s, and then ds was a little faster. Okay, so again, you guys, it's the vocabulary words are, our main focus. So relative error, differential, linearization, those are our new words from this section. So in section 2.9, and some of the new words are linearization, which for Calc 1 means the same thing as the tangent line. And then differential means dy, which is technically the difference in y's on tangent line. But it's also equal to the derivative, so y prime times dx. And then relative error means the error divided by the original function value. And then usually you express it as a percent. So I would go ahead and turn that into a percent.